Hello, this is Lars Minsaas, and this is assignment 2. So let's just go over this. So briefly show a code working on a simpler case. So we'll just run this, and I can talk a little bit about it in the meantime. So in a simple case, we can use two ellipses with focal points that are relatively close to each other and with widths that do not overlap much. For example, considering the following. Ellipse 1 with a focal point of 2, 3 and 4, 3, and a width of 4. And then ellipse 2 with 4, 2, 6, 4, and a width of 5. So as we can see, this setup is simpler because the focal points and widths are straightforward and result in minimal overlap, making it easier to visualize and understand. So we have an overlap of 4.8, which is not that much. So and then we need to show working on a more complicated example. So that could be, for example, 0, 0, and then 10, 10 and 0, 10 and 3. Let's just do that, and then 4 and 20. So that should be a little more. So this setup is more complex because the larger distances between the focal points and the wider ellipses increases the potential for a more intricate overlap region, making it more challenging to estimate the area accurately. Yeah, so we have 40 now, which is a little bit higher. Okay, present your ellipse class ellipse. So the ellipse class represents an ellipse defined by two focal points and the width of the major axis. Each ellipse is initialized with 2-point metal objects representing the focal points and numerical value representing the widths. This class encapsulates these attributes and provides a clear structure for presenting ellipses in the 2D space. Show the main accept reject loop of your algorithm. So the main accept reject loop of the algorithm is found in the function that computes the overlap area of the two ellipses. This loop generates random points with a bounding box that contains both ellipses. It checks if each random point is inside both ellipses, and it counts the number of points that fall within the overlap area, and uses the proportion of points that fall within the overlap to estimate the area of overlap. The loop effectively samples random points and applies the accept reject method to estimate the area of overlap between the two ellipses. That will be all. Thank you.